get started. Hello to everyone joining or folks on the recording, maybe watching in the future. Today, we're going to focus on MimioSTEM, but also primarily healthcare education, health science in practice and in the classroom. And we're going to find out a little bit about how some of the MimioSTEM product lines can assist with healthcare education, but also how some of our STEM focus, like 3D printers, more generally are in use in the education sphere and the healthcare sphere. So there's really a lot of cool sort of inspirational things going on right now in health sciences and the intersection with 3D printing. We're going to get into some of that, some really cool stuff that just blows my mind, even as a former biologist myself. So let's get started. If we haven't met before, again, my name is Evan. I've done a few of these STEM trainings in the past. Definitely seen me around STEM Wednesdays in previous weeks and months, but I work as a trainer with the organization here, and I actually used to be a biologist before this part of my career, and I taught a lot of med students, pre-med students for the most part, people who were joining really at the sort of the freshman college level, hoping to go on to healthcare careers. So I'm going to reach back into that part of my memory and we can talk about some things in regards to healthcare education. So let's get started quick with an audience question. If anyone's out there who wants to just type in the chat, I would love to hear from you. Do you consider healthcare to be a STEM career? Take a quick poll here. I'm not going to launch anything in Zoom or anything like that. Just let me know in the chat. We've got Kate in the audience with an emphatic yes. Jillian also with a yes. I believe we had a yes in the... Okay. We got an absolutely, even the non-doctors and nurses. Okay, so it sounds like, based on our responses, the audience here is on my side. I also definitely consider healthcare a STEM career. But surprisingly enough, that is not a universal opinion. So if you look up, what is a STEM career, STEM choices, what are the most in-demand STEM jobs? All those types of searches, it's actually pretty uncommon to see healthcare in there. So I'm of the opinion that if you have to learn a bunch of science to do your job, you're probably doing science or at least something close enough adjacent to it that it still counts. But a lot of places, just so you know, if you're looking this sort of stuff up, will actually separate out things like life sciences and healthcare. So this is a quick breakdown done by the Brookings Institute of STEM careers, the percentage of people in each of these careers. And you can see when you bundle healthcare in with the rest of STEM, it's actually the most common STEM career. So if you take it out, obviously, I think we're going to see like computer and mathematical sciences, programming, coding, that sort of thing takes the dominant spot. But if you do count healthcare, we're looking at the most popular STEM career. So if you're teaching a STEM class or having a STEM club after school, just be aware a lot of the students are probably going to be looking towards the healthcare and life sciences area, maybe more than you might have guessed, if you're much more focused on the physics or engineering, mathematics side of things. So just keep in mind that those students are out there. And this is a really popular career choice for a lot of people. And we always want to, keep building up the prevalence of women and girls in STEM. We've done a few sessions on that in the past. If anybody's on YouTube looking at our playlist, feel free to scroll up and see some of our earlier sessions on topics related to this. But you can see here, this data from the National Science Foundation, if you look at science degrees, and also just STEM careers or degrees more broadly, the only ones that are dominated by women right now are things that are either most likely leading into healthcare or healthcare adjacent. So psychology, biology, those are very much very diverse fields. A lot of women are entering and getting those degree programs far more than things like engineering and physics. So while, of course, we want to promote women and girls to enter those other fields, if we're looking at where women in STEM are currently, they're in healthcare for the most part and other biology and psychology related degrees. So just keep that in mind as well about the population of students who might be interested in this sort of thing and it might be interested in pursuing a career in the future in this area. It's probably going to have a lot more women in that category than some of these other career paths. So just something to note, and definitely something to keep in mind as you're putting together, your curriculum, trying to decide what you want to focus on. If you're going to do like an overview of STEM careers, or like I said, an after-school club, that keep these potential career paths in mind. Now, we're not really going to spend much time today on what MimioSTEM specifically offers. We're taking a much broader view here of the whole industry. But if you are in the market for STEM products or you're interested in our products, maybe you already have some of them in your school. I thought that there were three really main things that we could take a look at when in regards to healthcare. The first is probably the most straightforward, right? We have our lab disk portable STEM labs. These are your data loggers. So any healthcare related data for a biology type experiment, you're going to probably want to use a lab disk to collect that information. So that's a pretty obvious one. We're actually not going to be spending too much time on the lab disk because I think most folks, especially if you are a science educator, it's very obvious how you might use the lab disk in a lab experiment. But then our other options here, we've got our 3D printer lineup, and we're going to be talking 3D printers in general, not necessarily the capabilities of our own 3D printers, but if you have robo printers or if you have any other kind of 3D printers, definitely lots of useful information coming up about how that can work with healthcare education. And then, of course, we have our MySTEM Kits curriculum, which is really that, overarching product that ties this all together. We've got lesson plans and pre-developed kits, 3D printables that are all, tied into relevant education standards and across different subject areas. So we have actually quite a bit of life sciences material in there, things that you could use with healthcare. So we're going to talk about what is on MySTEM kits and also where else you might go to find cool things like anatomical models or surgical tools and that sort of thing that you might want to use your 3D printer for. So let's open up another question to the audience. I told you we weren't going to spend too much time on lab disk, but we are just going to, request a little bit more participation from you on this one. Can you think of any ways to use the lab disk to perform something like a health science experiment that you would use in a classroom? Anybody familiar with what the lab disk does? Feel free to answer. If you're not familiar, I'll give you a quick overview while you think about this question. So again, how would you use this with a health experiment? I'm going to open up the list of sensors here. So essentially the lab disk is an all-in-one little bundle of sensors. Lots of really great things in here. For example, we've got temperature, light, humidity, etc., that you might use in almost any scientific pursuit. But the biochemistry model particularly has a lot of really useful sensors for a health experiment. We've got an answer in the chat about heart rate experiments with sensors before and after exercise. Absolutely. So the biochem model has a heart rate sensor that comes right in the box, really user-friendly, especially for those younger students who might be a little bit more intimidated by some of that more elaborate lab setup. It's just plugs right into the lab disk and it tells you there either on the screen or on the computer what your heart rate is. I thought about actually having it go in the background, but I figured I could do with a few less cables running around my setup area here. Oh, yep. We also have another participant in the chat. Kate also thought of heart rate. Definitely. I think that is probably the most obvious if you're aware of the sensor suite in the lab disk. We've got an option for how temperature changes in different scenarios. Yes, definitely. As well as a ping for GPS, which I think is a really interesting idea. I hadn't thought of GPS, but I'm sure you could tie it in some way. The lab disk does have a built-in GPS, so you can just use that device instead of anything a little bit more fragile like a mobile phone. But I put together a list of some of the sensors on these lab disks that would be really useful in a health context. We've got heart rate, top of the line, absolutely. We also have temperature, which came up in the chat, so I was glad to see that. There is temperature that can be used with a temperature probe or the whole device temperature. So you can do ambient air temperature, but probably with a more health sciences experiment, you'd be taking the temperature of an object, and you can do that with a probe. pH and conductivity and dissolved oxygen are also really key concepts in the life sciences, understanding how bodies work and optimal ranges, homeostasis, maintaining pH, testing the gradient of ion concentrations across different barriers with conductivity. Those are all really useful concepts that you could learn more about in a lab environment and then apply to the human body or animals if you're looking at vet science. We've also got a chat here about pH in food and drink. Yes, definitely. Not only does your body need to maintain a consistent pH, but the things that you put in your body are, either very close to that or in some cases quite far away from our natural pH. Lots of cool stuff. So if you can see the chat, we've got a lot of activity about some lessons that are out there. And then also some case studies for teachers using some of these sensors. So that is all great. But I thought, like I said, the lab sensors are kind of where most people would think first when it comes to learning about biology. But there's a lot you can use 3D printers for too, if you have access to them. If you don't have 3D printers in your school, not only do we provide them, but you can also go, in most cases, to public libraries will have 3D printers. So you may have one for your district or your school, maybe even in your school's library. But then also there are usually some available more for the general public if you wanted to create some manipulatives for your students and just don't have the opportunity otherwise. But I'll take you through a few options for how you might use these materials in your class and sort of break this down into three categories. So the first one is anatomical models. Anatomical models are something that are really difficult to get your hands on sometimes as an educator. They're very expensive. They may, break easily. A lot of biological items are very small and very delicate. So, you're thinking about things like organ structures or, diagrams of skin membranes, the little models that you put together. A lot of those, are not so easy to come by, especially if it's rarer items. We're taking a healthcare look today, but we also have, for example, this collection of hominin skulls here. You're not really going to order a collection of hominin skulls in most cases. You might be teaching biological evolution, but you probably don't have all those manipulatives on hand, things like beak structures or claws or teeth. A lot of really great stuff that you can create your own manipulatives to really drive that concept home to the students. So I'll take you through what we have, at least a little bit of what we have in the MimioSTEM Kits curriculum, and then I'm going to show you a few other places to look online as well. Great resources out there. So if I click this link here, let's head over to MimioSTEM Kits. This again is our 3D printing and lab and robotics curriculum. We've got a lot of great lessons here, and we are hard at work adding new ones, such as this bird feeder kit and just recently letters combinations. Really great stuff. I went ahead and favorited some biology, life sciences lessons that I thought would be really useful. For example, we've got our brain anatomy, cells, human body. So I'll just take a look at some of these for you so you can see the kinds of resources that are out there through our platform. So this obviously is a really great tool for understanding how different parts of the human body fit together, are organized, what are actually all of these organs that we're learning about. And you can see it's even tied into a heart rate lesson using the lab disc, like we already mentioned. But you can choose, in this case, an entire set of organs, or maybe print one at a time. It's a really underrated feature of 3D printers that if your students maybe break something or lose something, you don't have to go back to the manufacturer of these kits and order a replacement part. Could be very difficult to do that in some cases. You could print your own. For example, with this brain, we can decide to print the entire brain with this set or individual parts. So maybe you just need a cerebellum because it fell off in the closet and, over summer break, something happened to it. You can just make your own again, really easy. So that, I think, is a really great tool to use a 3D printer for, because a lot of these structures are either invisible normally, like the human brain. Nobody's really seen a brain in most cases. And they're also complex and hard to understand. So it's really difficult to understand without a model like this, what different structures do, how they interact together, where they all fit. And really wrap your head around the spatial organization of some of these things. A 3D model, I think, is still the best way to go about that understanding. Obviously, there's animations and videos and all that available, but having something tangible, having something that can actually be, manipulated directly by the student makes a big difference. Also, for those of you in attendance right now, we've got some really great links in the chat that I'm sure will also be maybe in the description of our recording as well, if you're looking on YouTube. Things coming in with lessons and case studies, links for you to check out. Now, in case you are maybe not a member of the MimioSTEM Kits curriculum, or if you are looking for something really more advanced, you have some older students who really want to take this to the next level. For example, where I used to teach in the university, this would be a great tool beyond that K-12 level. There are actually a lot of free resources out there online for really detailed, complex anatomical structures. So the NIH, the National Institutes of Health, actually has an entire 3D model library. And the stuff that is available here is just mind-blowing to me. We've got pathogens, so microscopic organisms that you're never going to be able to really see in any detail, even with a really precise microscope. You can get such detailed look at some of this stuff that it really blows my mind. And this, trust me, this is the kind of stuff that a student needs to be able to see in this kind of level of detail to really understand some of these structures and processes. So obviously we've got a lot of microbiology here, but we also have, some of larger items here, articulated skeletons, different parts of the human anatomy, really high quality 3D models that you can just download. Not all of these are going to be easy to print. In fact, many of them could be quite challenging, but I have noticed that on many of these print files, when you download them, they actually have some that are labeled as easier for 3D printing. They might have built-in supports. They might have thickened some structures a little bit more than true to life, just so they are actually possible to print. So really useful items here. In case you're wondering where to print these, there's going to be a download section on any of these, and you can look for STLs. You can look for ones labeled print, and sometimes you can even look to see if there are items that have already been built. So if you build, instead of looking for 3D models, you can look for 3D prints that people have created and a nice picture to prove that it's possible, that this structure actually works by printing. So really cool stuff with some of these items. Let's talk about a few more options. If you have really enterprising students, you don't necessarily have to go out and grab models, especially if you're talking about external things like the human hand or the human head, structures that are easily, done in person. Maybe you have some organs that you're dissecting in your lab and you would like to create a 3D model of those organs to use in instruction going forward. You can have, that sheep's eye or that heart or the frog. You can actually create your own 3D models and really pretty easy. You can see I created a model of my own face just this morning in about 15 minutes. And most of that was processing time on the phone, not time that I had to spend doing it. So I made these with this app. It's called WiDAR. This is a free application, although you can, I believe, get 5 free scans a month, or maybe it was a week. I don't know. It's not unlimited. But if you're making just a few, that's totally doable. Of course, you can also subscribe to their service for more processing power. But if you have a really good use case as something that you can't find online, go ahead and experiment with creating your own 3D models and structures. It's really not as hard as you might think. All right. Now, some other options here that we'll fly through here, because I know we're running a little short on time in terms of getting you out of here to move on with your day. But my STEM kits also has models that simplify complex processes. Cell organelles don't really look like this. This is a very simplified version. Lipid bilayers here, a lot more complex twists and turns in real life, but students don't always need all that complexity. This really breaks it down for them. And you can see here that this is really very visual, helpful way to lay this out. My favorite one might be the ribosome transcribing and translating DNA into a protein. Really great stuff available on my STEM kits as well. I'm sure Hannah can put a link in the chat to some of those if that's a possibility. And then also moving on to more like the professional uses of 3D printing in healthcare, people are actually printing functional tools. So these could be surgical instruments or, in this case, tools that are actually being used in inserting into the human body. Most of the time, you're not going to be doing that with sort of the traditional 3D printers like you might have access to in a classroom. But the process is much the same. And you could give students a really hands-on look at the kinds of items and the kinds of tools that are out there to be used. There's also the whole aspect of prosthetics. There is an organization called Enable that actually has sort of an open source 3D printing collective for developing and creating prosthetics for people who don't otherwise have access to them. So not only can you and your students get involved in creating some of these designs, but you could also just go ahead and use your 3D printers to create physical models of these and then send those to people who would actually need them. So lots of really great stuff on the prosthetics front as well, a really creative outlet, especially if you have students who are interested in both engineering and healthcare. It's the perfect intersection of those. All right, so I have a few more links to share with you that you can view on your own time if you want, but I found some really great case studies for people that are using 3D printing in healthcare. The top one is Mayo Clinic. Mayo Clinic has actually had for almost a decade now, or actually, no, I think it was 2003, not 2013. I think maybe going on 20 years here, a 3D printing lab that they use with their doctors. Doctors will 3D print things like CT scans to understand where a tumor is or where important blood vessels or neurons are, and then practice their operations in advance, consult with their team to determine exactly what they're going to do, and well as showing patients what exactly is going on in their body. Really great stuff there. And then maybe even sort of in the realm of science fiction, it's becoming more and more possible to actually use 3D printing technology, although a little bit different than most commercially available 3D printers, possible to start printing human organs and human tissues in order to, recover from accidents or supplement organs, transplants. Really great stuff, really cutting edge. This is still coming for the most part. Practical applications for this are still a ways away. But if your students are interested in where the medical field is going and where something like a 3D printer could take them, if they're understanding that technology, that process, getting comfortable with that, as a technique, then they really could create great things going on in the near future. I think bioprinting is going to be huge once we work out some of the, early kinks in that process. It's going to be transformative to be able to build tissues and organs on demand. So that is a little bit. Oh, thank you. I was just alerted in the chat that I was sending some links out to just the hosts and panelists. So I'm going to resend those links right now to everyone. There's the Mayo Clinic link and the 3D printing link. There you go for bioprinting. Thank you so much. Zoom always likes to control who I send my messages to, and sometimes it's not everybody. All right, so that's a little bit about how you could use either the MimioSTEM lineup or any type of 3D printer and resources such as 3D modeling in the healthcare field, and how professionals are using it right now. So lots of cool, inspirational things to share with your students, and hopefully some ideas to foster cool activities or build some sort of healthcare enthusiasm among your students. So thanks for your time today. I want to let you know I'll be back next week for another biology-focused STEM Wednesday. We're going to be taking a look at frogs this time, reaching way back to my own graduate school career, and celebrating Leap Day at the same time. We thought leaping animals would be a fun way to celebrate Leap Day. So if you're looking for an activity to do with your students, feel free to come back next week at the same time, 4 p.m. Eastern. We'll see you there. Thanks, everyone.